of LACNIC. I work in LACNIC in R&D. We will start the tutorial called How to Protect Global Routing, What to Do Today, What's Coming Tomorrow. And before we start, let me tell you what the agenda is. There will be tutorials in a parallel in side event. Recursos Milacnic and in Mesoamerica the DNS presentation and internet identifiers. Well, here we have the tutorial on how to protect global routing. For this tutorial, I invite Erika Vega, who will be with us. She belongs to the board of LACNOG. She coordinates the routing working group, and she's part of the Manner Steering Committee. Welcome, Erika. So now, let us, if you bear with us a couple of minutes before we start.
Hola. Hola, hola. No, porque como si me paro, si me pongo de pie, ¿cómo lo saco? Bueno, si quieren,
Well, those of you sitting there the side, please join us here. If you sit here near the center, it will be better for the interaction in the tutorial. Today we're going to have two parts in the tutorial. We're going to start with the part what's happening at present with routing security. What actions should we take today? What is available? What's being used at present? We'll have a brief break, and then we'll go on with what's coming in the future.
So we'll now show all the theoretical aspects of routing security first. What we'll be covering this morning will be complemented with the laboratory and the practice session during the afternoon. This afternoon, you'll all have the opportunity of configuring a real scenario with all the information we'll be describing in the morning. Right now, we will start with the most common routing incidents that you have that you might have globally, and based on that we'll go over to the best practices that we want to share with you today during the tutorial. So thank you. Thank you to all of you who joined us this morning. Will we have microphones in the aisles? So if you wish, when we let you know that there's time for we have the Q&A session, you can go up to the microphones.
Bueno,
So, as Erika said, we will now be referring to the problems we have today globally in routing. What are the most frequent routing incidents that we have? In addition to that, we'll be looking at some of the data on the incidents we have today globally in the region, as well as what other techniques we currently have in order to mitigate those incidents also that these do not occur. And as we go on, we will be sharing with you the things that are being proposed at the IETF, which haven't yet been adopted massively, but which are new proposals in order to supplement what we already have. So, as I was saying, we'll be explaining things as we go along, but please feel free to interact, both those of you who are here in person and those who are following us through Zoom. So we won't have labs right now, but you will be able to follow what we're doing in your laptops. And after lunch, we'll have the practical aspect, which is the laboratory where you can start configuring the routers, as well as testing scenarios where you can do the simulations as if you were an IXP or a provider, and then apply all the things that we'll be doing now. So let us start now with the routing incidents. Let us look at the main routing incidents that we have today. First of all, what is a route hijacking? This is one of the most frequent incidents. One of those that are more complex. So what does consist in? Route hijacking. It consists in announcing resources that we shouldn't be announcing. So an organization announces prefixes that are not authorized to be announced in the internet. So you normally receive your IP addresses, IPv4, IPv6 in your autonomous system through the regional registry, for example, through LACNIC, or if you are connected with other operators, you'll be announcing through BGP, which are those addresses that were assigned. But what would occur if you announce addresses that were not assigned to you and addresses that belong to others? That is likely to lead to route hijacking. So if you announce prefixes that you're not authorized to announce, whether intentionally or as a result of an error. Today, most of the route hijacks are configuration errors, so it's very important to take these things into account. Then we also have intentional hijackings, and this is done in order to lead the traffic to another autonomous system and do something with that traffic. For example, inspect it or steal credentials or other things. We have had cases of Bitcoin theft, DNS issues as well. So if you change the DNS server that is used for a purpose and replace it with another, then you can change all the sites to which traffic is addressed. In this case, we have a client with 2001 DB8FF00:20. The client is connected to Autonomous System 65001, 65501, and want to access that address 2001 DB8F00:20. If you look at this IP range, it is over here in this autonomous system. Autonomous System 65010 has the range 2001 DB8FF00/40. This one down here has an IPv4 address. So how does this work in the internet? Normally, this autonomous system 65510 publishes that address range to 65502, 65509 too. So 65502 will have a table containing the two routes, 2001 DB8 to 65510 and the other one to 65509. So that is normal routing through BGP in the internet. 65502, once it has these two routes, these are published towards the other autonomous systems. So 65501 will have the two same routes now with the AS path, which is a full AS path. 65510 towards the right, which is the one that announces it, and the next one, which is 65502. That is the information that BGP manages, the prefixes plus the AS paths. So the client that is connected, once they reach to 2001 DB8FF00/40, it forwards the traffic to the provider. The client doesn't manage BGP normally. So they've forward the traffic to the provider. 65501 will look at the routes it has to reach 2001 DB8 and it will do the same with that traffic 65502 and will forward it to 65510. Normally, this is how internet routing works in the internet and also BGP, and based on that, the routes are created. The millions of routes that we have in the internet today. What would occur if 65509 decides to announce a prefix, which in this case is 2001 DB8FF00/48? You will note that this prefix is the same prefix as the one we have on the top, but this is more specific. The one at the top is /40, this is /48, the one down here. 65509 starts to announce it. So the initial question is, what does 65502 do? Does it have to accept it or not? Who knows? So I am 65509, I publish this prefix, and imagine you manage 65502 and you receive this publication of 65509. Is this right or is it wrong to announce that? Well, in principle, you don't know. You're managing that AS and you receive a 40 and a /48, and well, I wouldn't know. Initially, I don't know whether this is right or wrong. You might have some kind of mechanism whereby you communicated with 65509 and they sent you by letter which was the prefix it was going to announce or not. So in principle, 65502 had no reason for not accepting it, and it does accept it, and it includes it in its routing table. When this is included in its routing table as the best route for that AS48, it will also be communicated to other autonomous systems. 65501 no longer has one single route to 2001 DB8FF00, but it has a /40 plus a /48. So as you know, in the case of routing, the more specific leads to the less specific. Prevails over the less specific. So when it is forwarded to that address, traffic will then go in this direction over here. So what seems so simple is route hijacking. So all the traffic that I wish to access from client to this IP, so I want DB8FF00:20, instead of going to its destination, it reaches this other autonomous system, which is the one that did the hijacking. Imagine, for example, if this address is the address of a bank where you wish to access with your credentials or some other relevant information which you are managing traffic, which is a sensitive route. So this can do whatever it wishes with the traffic it receives. So this is what we call route hijacking. Now, why does this occur? This is because 65502 in principle has no way of deciding whether it can announce this block or not. If it can receive this block or not. Then there is another case which is quite frequent, which is that of route leaks. Route leaks are things that occur, for example, there are certain considerations that you have to take into account. For example, certain types of traffic that I learn in one place, I don't have to teach it in another place. So the prefixes that I learned from a provider should not be announced to another peer or to another provider. So if I receive prefixes from a provider, I don't need to announce these to another provider, because otherwise I create a path through the autonomous system. The same with the prefixes learned from a peer are not announced to other peers or to other providers. These prefixes, one of the things that we learn from a peer or from a provider, we only have to announce these in our own organization, or if we have clients, which is downstream. Now, in this case, for example, we have 65511. Autonomous System 65511 is a provider of the ones at the bottom, 65536 plus 65537. So there, each of these is announcing its own prefix, both upstream and downstream. 55536 is announcing 2001 DB810 upstream, and DB810 towards this other peer, and 2001 DB820 upstream. So this is quite normal. Peering, when you have peering between two different organizations, they announce the routes between one another and the two organizations and of the client of those organizations. This is what is happening here.
And obviously, each one will communicate it upstream to the providers. Now, what happens if this one does not configure any filters? So it is of 625.537, and what it announces, it will communicate it upstream. That's a leak. If this one lets us go by and announces it to its provider, then you will have a path that instead of going directly, it will come through this path, and that is not a good thing. In this case, we are seeing that with a route, but what typically happens is that as it doesn't have any configured filters, this provider allows many routes to go by, and it generates several. Well, it's quite inconvenient. On the one hand, it is slower. You make a saturation of links that was not foreseen. Very often you see that there's a leak of a complete table of the internet, and of course everything gets saturated and jammed, and so you shouldn't polish that through that autonomous system. Here it's simple, but if you had a longer path, you would be able to see that many of these paths come through here, so that would have affect the traffic of this autonomous system 65536. So that is an example. Now here, let me talk about the incidents. The main incidents that have occurred in the region, these are Manor statistics. Manor is Erika is part of the steering committee of Manors, and others are some incidents that were taken from September 2024 to September 2025, and you'll see at a global level the incidents both globally and in the region tend to go down if you see that in 2 years' time there's a clear drop. Today, we are in about 600, that would be the peak up there, global incidents, and almost 150 in the region, and still dropping. You see that it varies a lot from one month to the other and many other things. The other day they were saying that the correlation between Mardi Gras Carnival and the drop in the incidents in the region, that happened in Panama, but also in Brazil. So when people are on holidays, you don't have so many routing incidents. That varies from one month to the other, but you see that there's a tendency for it to drop. In that chart, you see Manners calls it a bit different. They call it misorigination. Then you have route leaks. Misorigination is what we call the route hijack. It's the term that Manners uses. Just publish something with the different things, and we won't see the products. Those are things that should not appear in the internet, such as the private networks or ranges that have not been assigned, autonomous systems that have not been assigned, and that should not appear. We won't see that because that is much more simple. Each organization should put the filters only so as only to allow their own filters. The end clients should allow their prefixes and not from other ranges. So, what you see here, you can find this map. This is a report that we developed with Erika while she was mostly in charge. These are this is last year's report. We're describing the incidents in Latin America and the Caribbean. There's a top 5 countries, list of countries. The first 3 are Brazil, Argentina, and Colombia. In the chart, you can see them in colors. Of course, Brazil beats them all, but that has to do with the size of the country and the number of autonomous systems and addresses. So you can't compare. It's because it's much larger. However, well, then there are other countries such as Argentina, Colombia that have their own peculiarities. I recommend you to take a look at that study. There's also a post at LACNIC that summarizes the key data. And if you want to look for your own countries, you can check it there. And you click on the link and you'll see that better. For instance, among the 3 top 3, the 3 that have more incidents, Brazil, Argentina, and Colombia, here you have the figures. There are some differences. For instance, in Brazil, there's a higher percentage of hijacks. In these 3 cases, there are no route leaks, 0. In other cases, yes. If you see the details, you see that there are more route leaks. Not in this case. Here there are only hijacks and bogans. There you see in Argentina, and then in Colombia. Well, you see that in Colombia there is 48.5 hijacks. And well, Erika will say that it's because they have implemented RPKI. So you see how they differ. Brazil has a much higher percentage of hijacks, 85%, than the rest of the countries. Why does that happen? Well, it may be the case that Brazil adopted RPKI later, so it has not been uptaken so much. But as a matter of fact, by adopting these measures, you reduce the incidence, and you could see that in the long term in the previous chart. And there are even some study cases where you can clearly see that by adopting some measures that we are going to mention, thanks to that, the incidents do not grow and get disseminated as was the case in the past. Now, you already know what the routing incidents that we want to avoid are. We try to prevent them from happening, and now Erika will tell you about the manners standards and what we can do to prevent those incidents from happening. It's not so easy to come to the rostrum. Well, Guillermo showed you the statistics of the incidents, and it's quite comprehensive. We wanted to highlight the three top 5 countries with more incidents. It's quite striking to realize that the highest percentage is in the bogus announcements. Those are all the route announcements that typically we know that we should not be published to the internet, that are all those private networks, for instance, all the segments that are reserved for testing, and all the addresses, for instance, loopback and addresses that have not been assigned and that we reserve for documentation, private segments. That is quite striking. I was personally quite struck to see that more than half the percentage of the incidents occurring in Colombia would be because of bogus. Now, there are different actions that we can execute in the configurations that we establish in our infrastructure to be able to prevent those announcements from happening, so that we can also cover our infrastructure and receiving them. Remember that in the entire scheme of how ISP works, everything we announce is going to be repeated by the peers we are connected to, but then they will publish all that information to the other peers, and it is there that you have a cascade effect where you start seeing incidents from one point, and in just a few minutes it is replicated from one network to the other, and the other way around too. Maybe an incident that they generated in some other continent will affect our network. So we have different actions that we typically know that we execute. For instance, filters that we put in the configurations in our route where we receive our routes. And we have other actions that are more specific, for instance, to prevent the publications of fake ISPs or receiving fake ISPs, creating lists of access. And so we see this huge growth of incidents, and it is because of the new networks that we have in part that it is necessary to create a framework where we can establish a framework where we can establish specific actions to execute in our infrastructure so that we can prevent these incidents, so that there we have a manners. How many of you have heard about this initiative, Manners? Raise your hands. So we have some, but there are just a few. Manners is a global initiative. These are the mutually agreed norms for routing security, and they focus on generating this framework with some specific actions to improve security, reliability of this global routing system, essentially by raising awareness among the people that operate the networks, and also promoting an increasing group of support, where not only do we have the people that operate the networks, but other groups that are increasingly important in the internet system, such as content providers, cloud service providers, the vendors, points of exchange points, internet points. And so we have support groups that establish specific issues. So we are raising awareness. We are responsible for executing those actions in the infrastructure, and we have a collective responsibility with the other infrastructures to generate those actions and to protect, both create shields for our networks and others. And we want to show that capability of solving problems, so that when we generate any incidents, we may also be able to respond to these incidents quickly and effectively. So we have, well, manners specifically. The will tell us what to do. And they focus on solving three types of specific problems. Those related to the incorrect routing information. So these are the cases that Guillermo described. For instance, the route leaks and the bogans that we can announce from our infrastructure, and also this part of route hijacking. We announce prefixes from an autonomous system that you are not allowed to announce, and generate incidents like this, and related to the IP tracks with a fake origin that is generating to generate spoofing in infrastructure, and those related to coordination and collaboration between the network operators to respond immediately to mitigate these incidents. Well, the programs Manners offers at present are four. The first was the network operators. It's a large group of us in charge of those actions. All the internet providers, all the entities that manage IPv4 and IPv6 resources and ASNs. We have a specific program for IXPs. We have an increasing number of IXPs in the countries and in a region. As a matter of fact, there's an organization that is LAC-IX that gathers them all. So we have quite a large group of all the IXPs today. And then another specific program for the contents providers, the ASNs, and the cloud service providers, and the program for vendors.
So this is an initiative with more and more members. This is a certification that is achieved, for example, if as internet service providers we carry out and implement the actions, we would then be certified in compliance with Manners. This is a global initiative. Initially, this was developed by the Internet Society and currently is guided by the Cyber Alliance organization. They promote the adoption of this initiative and certify the networks that carry out these actions. So today we'll be focusing on the actions described for the network operators group, specifically with these four actions. These show specifically which are the configurations for each of the actions that we want to implement in our infrastructures in order to do proper routing and achieve coordination and communication between the network operators. As I mentioned initially, we have the filtering action. This action is something we are quite familiar with when we start doing the initial analysis to execute this action. We see that it has quite a high percentage in the infrastructures. Most of the configurations have been done in terms of filtering. And initially, so you can obtain this certification, you will conduct a current diagnosis of your infrastructure, what you have already executed, and what you would have to achieve in addition to what you already have so that you can obtain the certification. Sometimes these are minor actions that you have to take in this regard. Then we have the anti-spoofing action from the four actions that I mentioned. The anti-spoofing action is not mandatory in order to obtain the certification. In the case of anti-spoofing, we focus on the configuration of access list of the ASLs. These are some mechanisms in the interface of the devices where you have to block the addressing which could be false, as well as the mechanisms. If we are a large internet provider, we use this in order to validate that the prefixes that we are announcing to our clients are in fact from them and have been assigned to them. We then have the coordination action. This is one of the easiest to execute. It contains all the information we deliver publicly in order to rapidly contact these when we have some kind of incident. These are global databases where we have to register our information. Can you think of any database where we normally do the search? We have an AS number or a prefix, so you want to know who this belongs to. What database can you think of when the first one we start thinking of when we wish to do a query? Any ideas, any suggestions? The Whois, for example. Yes, somebody said Whois. This is a global database which we feed with our own information. And from those databases through to those containing more specific information or detailed information such as PeeringDB, we can provide information of what we have in our own infrastructure, but what is even more important, what we announce, how we announce this, and who could provide support or respond in the event of an incident. But at present, today, we're going to focus on this action over here. This is one that we highlighted. This is the fourth type of action contained in this manner's certification. This is the global validation. This global validation includes different mechanisms and configurations that we can do in our infrastructure in order to mitigate incorrect routing information. Like I mentioned, we will also be able to validate that the networks and the information we receive are correct. It has the correct origin, and there are different mechanisms that we can use. So we will now look at the explanation of what these actions are in order to comply with the global validation requirement. As I said, there are different mechanisms. I'm sure that many of you are already implementing these, like the filtering, like the access list, and so on. So all this framework allows us to have everything in the same basket and have these actions to determine whether we are implementing these or not, and the networks with which we relate for peering purposes can provide greater reliability in this routing system globally. So focusing on this global validation, we will now proceed to explain which are the mechanisms that we'll apply for global validation purposes. Let's see if this responds. So before proceeding to that, I would like to mention, I was saying this is a global certification. Actions are identified for these 4 programs that I mentioned that work within manners. As network operators, we will start to implement such actions, and we'll be able to identify that in some of the implementations, when we receive the check mark that we are complying with that, or that we have tools that we can validate and so on, provides us with the information that we require. Or also, it might be difficult in some of the cases, and for some internet service providers, for them it is difficult to meet with this action where they have to generate a whole number of access lists and we don't have a mechanism to automate that generation. So we can send comments or request information regarding this process of the manner certification. This is done personally. We are not representing any organization, but as network operators who are familiar with the infrastructure we have, and if we note that there is something that is not related to how we're measuring things, we can send comments. So I'd like to invite you to be part of this process. If you start to work in the certification of this initiative and you note that some of the topics that are included can be further strengthened, or if these could be changed, adding tools, to please write this in the comments so that at the level of the board we can strengthen this forward. This is something that we have been working on for some years now. So these comments, the input from the community is very important. The idea is to be able to continue working on this. Now we have 4 programs. Initially, we only had one for the network operators, but we have more and more members now. But you need to provide the feedback and the input so that we know that through these actions, we can, in fact, manage to respond to the things we are tackling. So now we will explain these mechanisms that we have in the global validation. As Erica was saying, we will now focus on the action of manners that has to do with global validation. So that is where this question comes up. How do we obtain information beyond our autonomous system? You will recall the first example, the example on hijacking. This was an autonomous system that starts to announce a prefix, and we don't know prior to that, once you receive it, whether that prefix that is announced should be announced by that autonomous system or not. In the example we gave, we have an interconnection to autonomous systems 65501 and 65502. 65501, when it announces it, it should know what it should be announcing. There's no issue in that sense. 65501 can do things badly and announce things that should not correspond. But in general terms, if you're going to publish and interconnect with BGP, you should know which are the networks that you have to publish. And this is because it is the networks in your organizations or those of your clients to which you provide traffic. If you have clients that wish to publish their networks in the internet, you know who those network clients are, which those networks are, and these are the ones that will be publishing this. 65501 knows what is happening on the left side of the screen. Their own networks, their clients' networks. When they publish this, they should publish filters in BGP through prefixes, through ASPath, or through communities in different ways to be sure that it only publishes what should be published. So that is one of the ways of doing filtering in BGP. You connect to another organization, you don't publish everything, just publish what should be published. So this is what you have to do as an interconnected organization. Now, the problem is when you accept prefixes and you will be publishing those things. So 65502, what should it publish? Well, you don't know. So it could publish a default route. Do you accept it or not? It could publish a set of routes. It could publish the 65502 routes alone, or it could also have others behind that can publish these. So 65501 has no way to determine prior to that what it has to learn from 6502, which prefixes, what are the autonomous systems behind it, what are the announcements those systems make, and so on. So that is where the problem lies. As you see at the top, the announcements are quite straightforward. You know your organization, you know who your clients are, you know how you will be filtering this. And this is done with the BGP filters. This is the most traditional way. When you receive this from others, you don't know what the other one will publish, so you have no way to determine whether what they are publishing is correct or not. So here is where we have the IRR versus RPKI topics. So what do we need? As I mentioned, in the case of BGP, you have no way to know whether that autonomous system can publish the networks or not. If it is public, you have to decide whether you accept it or not. So you have these two functionalities, which are like two external databases to the BGP, external to the routers. Namely, they are ways to check whether the information received by BGP is correct. So BGP has no intrinsic mechanisms to verify this. In BGP, you'll see this this afternoon when we are in the lab. You will then see how you put BGP in the network, you enter the route, and directly it starts to publish that in other directions. And you have no other mechanism. It's not that BGP has something that allows you to see whether the prefixes was already announced or not. You just publish it and that's it. So the way in contrasting this is through external databases. These are two different mechanisms. One is that of the IRR, Internet Routing Registries, and the other one is RPKI. What the organizations do in this case is, well, these are the prefixes I will be publishing with my autonomous system, or my autonomous system will originate these prefixes, and that's the list. So when you are on the other end, you will be able to check whether the autonomous system is telling you that it will be publishing given prefixes. You have a way of determining whether the prefix should be published or not by the autonomous system. So that is where we have this external database.
What are the Internet Routing Registries? Well, this is an older mechanism. They started using this in the late 90s. And this is essentially a database with information that is in a certain format. The best known of these IRRs is RAB. In the case of LACNIC, it has an IRR that has some peculiarities. Now, and RADB is the best known. There are different organizations that have an IRR, an Internet Routing Registry that is used for publishing the routes. In that database, the organizations define their routing policy, what they will publish and how they will do it, and then the operators will generate that to generate cycles. Very often they can generate it automatically. There are tools for that purpose. You'll see that you can use some tools to generate those filters. So this is one of the ways. It's an older way, and there the operators generate the information about the prefixes they are to publish. This is an example of the type of registries that you find in an RIR. For instance, here on the top you have a Route 6 is an object that defines a prefix, an IPv6 prefix, and several data about this, particularly the origin. That's the third row. There you have it. It says that from in there in that those numbers, that address needs to be generated by 64135, that autonomous system. Then you have other data such as who keeps that registry and the maximum, the length that can be published with, etc. So with this information, then you know that if the prefix, the /24, is there and it is originated from another autonomous system that is not 64165, you would be in a position to reject it because it's not consistent with what is declared in the RIRs. We'll see this later in a while. On the other hand, RPKI is more modern. I think that it was developed in late 2010, or they started using it in 2010. It defines public key infrastructure to be applied in routing. The difference here, as compared to the previous one, is that it is more sound from the point of view of the updates and how you certify the validity of the data. So you have an RPKI with digital certificates, and you create a chain starting from the router, that is the regional registries. So you can check the cryptographic data to check that what you put in the RPKI is valid. So what happens here is that in LACNIC, the IPv4, IPv6 resources in an organization, be it an ISP or end user, in LACNIC, in addition to assigning addresses, will give them a digital certificate that in the case of most users, the certificate is stored in the MiLACNIC system. You won't see it, but believe me, it's like that. It's a certificate that attests that that organization has those resources. With that certificate, and its signature, you can sign objects that are ROAs. And so that is in the end what defines RPKI. In the case of the RIRs, that's a flat database where you, as a user, you authenticate yourself. And in the case of RPKI, everything is signed digitally. So these objects that are equivalent to the router, the IRR, they can also be signed digitally. You create an object, an ROA, that associates the addresses with the autonomous system of origin. And here it is signed digitally. In addition to that, RPKI defines, you remember that in the case of the RIR, I asked what could be done with that. Well, the organizations can create filters for the router. Sometimes you can automate it. In the afternoon, we'll see that that can be done automatically. And I said that there were tools for configuring the routers, and this is not part of a standard. But in the case of RPKI, there's a mechanism that's called validation of origin, and we'll see how it works. So remember these things. The route objects associate prefix with an autonomous system of origin. And here the associate the autonomous system. And in the case of RPKI, this is signed so that another organization won't create a fake ROA. Here, let's go through what we've already seen, and we'll ask some questions. Yes,
Sí, todavía tenemos tiempo.
Bueno, tenemos un rato todavía para el break, así que vamos a hacer vamos a hacer un repasito y después tenemos un par de
So we have a few minutes for the break.
Premios.
que
Yes, we have some small prizes. We thank the campus of LACNIC. I don't know whether Mariela and Sandra are here, but they were very generous. They donated some gifts because we have some questions. So now let's go through what we saw here. We started by describing the routing incidents, hijacks and leaks. Remember, the hijacking is announcing prefixes that we are not authorized or that don't belong to organization, so as to speak. What I'm saying is actually not correct, because obviously it's full of organizations that announce other people's prefixes. But the thing is that you are not authorized to publish it. That would be hijacking. Erika? Yes, and we discussed the mutually agreed norms for routing security. We discussed the best practices and the actions available and the programs under this framework, and specifically that we are going to focus on the network operators programs. We have 4 actions, and what we are explaining now, well, you have these mechanisms that Guillermo pointed out that we have to implement. Guillermo discussed our IRR and RPKI. This is part of action 4. Well, and then we just saw the mechanisms. Once we know this, what are the incidents? What is it that we wanted to avoid? What would be the best practices, and what are the mechanisms available to achieve that? So we'll see that in detail, but this is more or less what we discussed this morning. So far, do you have any questions so far? Any comments, any doubts? The participants are connected remotely via Zoom. Remember that you have the Q&A panel. You can write your questions there or your remarks, and we'll answer them from here. Okay, so let's see how we use these validation mechanisms. In the example, we have an example of a peering of the autonomous systems. Each has its own networks, one IPv6 and one IPv4, and we want to see, for instance, what we just mentioned, These organizations registered the prefixes in an RIR. We'll see the RIR first. These organizations have registered their prefixes in the RIR, and what we can do is, for instance, in 65501, do you remember what we mentioned at the beginning? In 65501, they know what they have to announce. However, they should know what prefixes they should receive from here. So it sends a query to the RIR, first of all requesting whether in the IPv4 and IPv6 system that this autonomous system has, or what they declared they would announce. What they do there is they send this query to whois. In the first query with that exclamation mark, it says what are the IPv6 prefixes that a 65502 has in the RIR, and the one at the bottom with the exclamation mark, what are the prefixes that 65502 has defined in the RIR. So you see that there's a very short list. Prefix /48 in the first case and a /24 in IPv4. Those you can see that here. This is the most basic thing, so that you may understand that if you do it now, if you send a query like this to any autonomous system, they will tell you what they have registered in the RIR. If they don't announce anything, then you won't see anything. You can do this with an autonomous system that you know, and they will give you a list of the prefixes. So here you have the information you needed. Oh, so we said that, well, let's go back. There. 65501, was in red, and you wondered where it came from. Well, now you know that what 65502 will announce. When you sent a query to the whois. You asked the RIR for the announcements. So now you can apply static filters, and that's it. RIR has an additional step or complexity that is not there in RPKI. It is the possibility of defining the AS. If here there are other things connected in addition to 65502. We would have to enable these other prefixes here, or at least the prefixes of the organization that 65502 will give transit to. It might be the case that 65502 only gives transit to the two ones on the top and not the one at the bottom. It's 502 that defines it. It's a provider. If you connect with other provider, you will have to pay that provider for you to allow you to transit to another part. So there may be cases where you only connect through peering, and so for 65502, there's no reason why it should allow it transit. So it's not so simple to know whether these publications can be there. That will highly depend on commercial relations among the organizations. That has nothing to do with the technical things, or not necessarily at least. 65502 will be able to define with these AS set, the set of autonomous systems it will give transit to. So how do you know that? Well, you ask the RIR, and somehow you need to know that ASC is there. That usually that AS set is defined by the organization, and it's called peering DB. And here you have a who is that AS set of the organizations that 65502 will give transit to. An AS set is nothing but a set of autonomous systems. It's the name there. In this case, it's called AS transit, and it's preceded by the number of the autonomous system and the members. This, if you send a query to the LACNIC system, you see that there are many of these AS set configured.
So that makes the query, knows the AS numbers, and then repeats the query in order to obtain this from each of the autonomous systems. Here we have an example. I don't know whether we can see it well, of how to create an AS set. This is just the interface at MiLACNIC, but the important thing is that you understand the concept, what it can be used for, when you want to create it or when you wish to use it. This is just an LACNOG AS set and all the autonomous systems. As I was saying, there are tools that allow you to facilitate this. If I would have to do each of these things, consult the AS set, obtain the autonomous system, to consult the whois and obtain the prefix list from each, and then prepare the entire access list, that is quite complex. So there are tools like this, BGP-Q4. You put the IRR you will be consulting. This is access list. This is Cisco format, but the AS set then shows you an IPv4 and IPv6. You have the access list that you should apply in the interface for the access router. This would only allow this IPv4, and it would allow these other two IPv6 ranges. You will note, if you look at the example I shared with you previously, this one over here, once you do the query for IPv4, you'll only obtain 509, which is 100/24, and you'll do the query, you obtain the two FF00 and the ABCD, and you will note that in the example you should obtain this over here, FF0 and ABCD and the IPv4 address. So in this way, you obtained the networks that have to allow this. So let us now make a demo so that you can see how the IRR works. So in this demo that Guillermo will share with you, the idea is to how you can use this IRR database to do queries and obtain information through this IRR mechanism, this database, so as to generate some type of filtering in your infrastructure, but also to define what Guillermo was sharing with you, which is AS set, and through which autonomous system it should go through, my publication should go through. So first of all, I'll give you an example of a simple query to the autonomous system. 28,000 is the one that LACNIC uses. You do whois -h. -h means that the query could RADB, which is the one that has the mirror of all. There are some IRRs that are more global IRRs that copy all the IRRs that are around. There are quite a number. So RADB or this one over here are the ones that you can consult in order to obtain the information. Here I did a query with the one from LACNIC, and I obtained information on the autonomous system, who maintains it, and so on. One of the other things that I can do is to do a query through an IP of LACNIC. I'm going to put one of LACNIC, but you can do this query as well and see what you get. Over here, I did a query with the address 207.84.0, which is one of the ones I recall, which is one of LACNIC. You will note that I obtained a route object. Remember, I spoke about the route object and Route 6 objects. If you were interconnecting with LACNIC, with the autonomous system 28,000, you would be able to know, well, in this case, you do know the network. But we will see now how you could generate the list of all the networks that you have. So what this object shows the address. It's prefix 23. I did a query with 84, but it shows me not 24, but 84 and 85. And the autonomous system at origin is 28,000, which is LACNIC's prefix. So there you have some information. There you have the maintainer object, one of the objects that you can use for making the query to the IRR is this in order to obtain the list of all the objects created under the maintainer. This is what you can see over here. This is the maintainer. So if we do this query that we have over here, as I was saying, these flags that you have over here, exclamation mark, the exclamation mark and the O, you can see in the link I gave you a couple of slides ago. You will be having these slides will be available in the website. So if you do this query, you will obtain all the objects created by this maintainer, which is LACNIC's maintainer. You'll get a very long list of things if you go back. You have AS set, for example, Anycast servers. Here you have an AS set, which is AS64845, that is Anycast server, servidores Anycast, and shows you which are the autonomous systems where apparently LACNIC has Anycast servers. Here we did a query. Let me show another one. The one I had just now, which is the one of LACNOG, which is the one you will be having this afternoon. In the case of this maintainer, it is LACNOG's maintainer. This is a query. It's the same one, but it's the maintainer. So I will obtain the addresses and the route objects as well as the AS that created by LACNOG. Here, only an IPv6 prefix has been assigned. This is a /32 IPv6 prefix, and LACNOG only has IPv6 prefixes. That is why we don't see a route object only. We have a /32 with the origin AS. Remember that the important thing over here is this association, the prefix and origin autonomous system, a /33, which is the same origin autonomous system, /34, and over here another /34, which is not the same one as we had previously with a different autonomous system. The previous one was 64.135, and this is 64.136. So this organization over here is saying that some prefixes are published by one autonomous system and the others are published with another autonomous system. And this is the information of the two autonomous systems. This over here is an AS set that you'll be seeing this afternoon, which is lab RPKI 42.1 that Nico will explain this afternoon. So these are the autonomous systems that allow you that can be used for in certain cases, 20,000, 8,000, 28,001, and so on. So as you can see, the AS sets can be for more than one function, and are defined over there. And you will see this later on. These can be used for filtering for the routes that you learn. Here we have one that is Lab Privado Tutores. If you wish, you can give us an autonomous system. We can check whether there are things that are created in IRR or not. And if you don't have created an AS set, we can nevertheless look at the objects, route and route 6, which are the segments that have been assigned to your organizations and that one that you're routing with your autonomous system. Anyone would like to give us an autonomous system in order to do a query? If so, go up to the microphone, and those who are participating remotely can also write this in the chat of the Zoom. Are you falling asleep, ladies and gentlemen? An autonomous system. Let's see over there. Let's see. Isn't it working? Hi, I'm Celsa Sanchez from NIC Chile. Autonomous 27678. So the first thing I do is doing a query, so AS27708 in order 678, sorry, in order to say, like Celsa said, this is the autonomous system of NIC Chile. So what I do is I take out the maintainer in order to see this over here. I'm going to do the same query, but changing it to the maintainer. So what I will get are all the objects created with that maintainer of that autonomous system. Let us scroll up. So there are quite a number of things over here. I'm trying to get back to the beginning, to scroll back to the beginning. Here we are. So we have a /23 prefix in IPv4 published with the autonomous system 27678 that she mentioned. We have a /24, which is a different range, 27678 as well. Here we have a /24 with another autonomous system.
O sea, hasta ahora veíamos dos.
So far, we have 2 publications.
What we declare is that the autonomous system that created these registries will create it. And here, this route object, 100 and this 270/24, the autonomous system of origin is AS52304. Yes, and you're also showing the maximum length by disaggregating the prefixes. And here too, what Erika just said, here you have a, well, this is a /22 and with a maximum length of 24. This would be making it possible for the autonomous system, this autonomous system to generate a /22, but it could be /23 or 24 in that range. Here we have several ASNs. Yes, and remote participants. Well, this one has many. It's interesting to see this. There are other autonomous system authorized. And, well, of course, IPv6. I don't know whether there are AS set. There you have all the prefixes published from the different autonomous systems. There's a long list. You can see this. You can use this command in your own terminals. Well, so let's ask the AS set. Well, this one here that indicates Fernando Leon, a remote participant AS 266783. All right, so let's do the same thing. Well, here it says Humberto Enriquez Mocayo. This is from Ecuador. And here, once again, we took the maintainer. We'll put it here. So let's see. Everything available. Here you have an AS set, ISL. Here you have two autonomous systems, 266783, and the other one. This one has an IP transit, although it doesn't say it here. Somewhere they indicate that this is the AS set with which they define which autonomous systems they'll give transit to. In this case, here you have the numbers and 264668. Another one called AS full. And this is very interesting because as part of the AS set, remember that I said that the members should be autonomous systems, so it didn't say that they could be other IS sets. In this case, it is sort of recursive. As members, they have other IS sets. Here you see IS transit, IS self, and IS CDM. Well, the transit is the one that we just saw. And here you have the other one, ASCDNs. There you see the numbers at 40027. So here you have a very complete example. There you have the networks. We saw that. It's just that each prefix with the autonomous system that originates it. I want to show BGP4 later. Yes, in just a few minutes. So let's do the query of the AS that Jenny sends us. Jenny Suntura, 26210, 26210. No entries in the IRR. Okay. 26210, yes. Yes, in this case, this autonomous system hasn't defined anything in the IRR. How does the IRR of LACNIC works? It's a bit different from what others do. And here, let me explain something that we haven't addressed yet. In the case of the RIRs, typically, the way they operate is that the one with an autonomous system defines the objects. So, for instance, here 26210, the one that manages autonomous system 26210 is the one that can create all the objects. So all those road 6 and road and the AS set is generated by 26010. In the case of the IRR of LACNIC, this information is generated mostly automatically from RPKI. In the case of LACNIC 26210, what they need to do is to create the ROAS in RPKI and then to enable the RIR. And then the LACNIC system will create directly from the ROA information and other information from the WHOIS. They will create all the road and the road 6 necessary. Now, what is not in RPKI is the sets. They would have to create it manually, those managing 26210. That autonomous system. But that's a very interesting piece of information. The one that manages this is the one that manages the autonomous system. In the case of RPKI, one more thing. If you use another IRR that is not LACNIC, normally what happens is that in a way you say, well, I am the manager of this autonomous system. For instance, here you register, you have to pay to use it, but you say, well, I'm this autonomous system, and once authorized, I'll be able to create objects with that autonomous system. But the authorization is not too sophisticated. After being authorized, you can create just anything with that autonomous system. In the case of RPKI, it's different. In the case of RPKI, you use an RPKI. So only those that have been assigned the certificate associated to the addresses will be the ones capable of creating the ROAs. And the one that creates the objects is not the owner of the autonomous system, but the so-called owner of the addresses, the ones that have been assigned the addresses. So the model is different. So here is those that have the addresses. Well, they say who will publish it, which autonomous system will publish it. And as I said earlier, in the case of IRR, in the case of LACNIC, they take all the information from the database of RPKI and generates it automatically, and manually you can define the AS sets, and we saw that there are several defined. I'm going to show you an example of how to use this. Do you remember the example that I gave you of LACNIC where you have the AS set? This one that has the 4 autonomous system and 28,000, 2000, 28,001, etc. So if I wanted to allow an ASL that will generate these with these autonomous systems, what I do, for instance, is this. I do a query to a LACNIC, and here I ask it to give me the IPv6 addresses. This is an access list. You can call it whatever. And here I use I just saw, and if this works, this should give me the IPv6 addresses. Here we can change the name. That generates a list of access to enable the IPv6 addresses of those of the autonomous systems that are mentioned in that AS set. Do you remember the AS set? It's this one. So what did the line do? It took each autonomous system and expanded the list of IPv6 addresses that the route objects of each of these. If I were to do this manual, I would have to take 28,000 and to remove it from the 202801 and all these here, 196,615, and to remove the list of addresses. So with this command, you already have this, and this can be directly applied in the interface of entry of the router. You configure this filter, and that would be enough. And you can do the same for IPv4. Let's remove the 6. And there you will have the list of the IPv6 addresses associated to those autonomous systems. I have these in Cisco format, but you can use it in other formats. For instance, MikroTik. This is quite a common case. So there you would have a format of a list of access to MikroTik, or it could be Juniper. Well, it depends on what you're using. I think that now it's clearer. You can better understand how it works. For instance, this, if you have router Juniper, this generates a list of access in Juniper format, and you can apply this in the BGP sessions that you have with that autonomous system, and you have the information you were lacking. All right. Well, I want to thank the remote participant, Jose Veres and Henry Galindo, who sent us, we're going to use you for another demo that we'll have for RPKI. So now let's go on with our presentation. We've completed this model of the part of RIR. And there, as Guillermo pointed out, Chicho, in the website of the event, if you enter the tutorial, you'll be able to see or to download the current presentation. So there you have all the references and the documents of everything we've shown so far, tools that will help you generate the first RIR of LACNIC so that you can create this Route 6. We have the tool that will explain the queries quite well. And everything that Guillermo said, specifically for this RIR, depending on the type of machines for the specific questions. And now let's go to validation of origin, more focused to the next mechanism, that is the use of RPKI. So we all saw the RIR. We already know what a database is. There are many databases in these internet router registries where you can enter the information of how you are publishing your prefixes, under what origin, what autonomous systems have the permit, the right to publish those prefixes. We can use that object, that the AS set, that makes it possible for us to indicate the AS that we are going to give transit through. We have different mechanisms that depend on our management and the way we generate the objects in the database to manage to give a response to these incidents that we saw at the beginning. Now we're going to the RPKI part, and here I want to show you our infrastructure for validation of origin. Here, what we want to show is how this part of RPKI works. Actually, in RPKI, we have these two big issues.
We have a validation infrastructure, which is what we see over here. In addition to that, the creation of digital certificates that are the ROAs. Guillermo, we like to call him Chicho, had already explained this and told about these digital certificates and how that signature signing worked. So it's important to be aware of that. One thing is to sign our certificates to generate our ROAs, and that these ROAs depend on how I'm publishing my resources, under what origin, under what autonomous system, and another one that is the validation infrastructure we have over here. And of course, it is necessary to understand where this information comes from, what the ROAs are, so that at some moment our routers, which are the ones that contain all the routing table, know or have information on the status of the routes. or that we can use the information that we have in RPKI.
Que tenemos unos repositorios.
So we will see that we have repositories, which are the ones that we have over here. These are repositories that include each of the internet registries regionally. In our case, this is LACNIC for Latin America and the Caribbean, but all of the other registries, we have 5 globally, that manage these IP resources, IPv6 resources, and autonomous systems. They all have their own repositories containing information on all these certificates. So these repositories are hosted in each of the registries, LACNIC, RIPE for Europe, AFRINIC in the case of Africa, APNIC, and ARIN for North America, that have these repositories. These repositories feed every now again with the certificates that we generated on our resources. That information will enter into those repositories. So we'll have a software, which is what we call the validating caches. These are in charge of doing the query to those repositories and bring back the information locally to our own infrastructure of the digital certificates that have been created.
Caches validadores.
So those validating caches will be doing the queries to the repositories, and the validating cache will be operating also in our own infrastructure. So the idea is that the validating cache will be physically in our infrastructure and will be somehow be able to connect with our router. Now, to which router will this validating cache router connect? With the one that has a routing table. So this is one of the best practices in terms of routing, namely not to announce the entire table, but not a default route. You have a default route. We cannot know all the segments that we are receiving and then make decisions as regards what we'll be doing with this validation of origin. So we'll have these validating caches in our infrastructure. These will be hosted locally and will connect with our routers, feeding them with the information brought locally from the ROAs, from these digital certificates. So this information uses the RTR protocol in order to informing our routers, and in this way our routers will learn that information, and we will begin to see an additional attribute in a routing table, which is the validation attribute. So this will be an additional attribute in this BGP table that we will see containing the information of a validity status. So with this information, and through updates and messages received from one router to another, we will be able to learn the information of the validity status of the routes that they are learning at BGP level. All this information will be obtained by that validating cache. When the routers receive this information on those caches, they will have a table containing the information of what they receive from the validating cache of all the ROAs created. This is a ROA, a table, with all multiple entries containing all the certificates of IPv4 and IPv6 segments. This is an enormous table, and we will have that information which will indicate which is that IPv4, IPv6 network, how it is broken down, if it is published completely. Here we have some examples. For example, this IPv4 prefix that we have over here, 200.112.0, which is a 22 length, but it has a maximum length of 24. So the Autonomous System 65501 is publishing this /22 prefix or /24, and this is already a ROA. It is covering that all those announcements from /22 to /24. In the case of the IPv6 example, we have /48 only. That certificate is being generated, so it can be announced by 65502. So it's a table with multiple entries that we'll have in our router. With that information, we will be able, as I said, we'll be adding will be very clearly seeing in the lab this afternoon. But this is an additional attribute that we will add to the routing table. Based on that, what we have to take into account in order to define the rows are the following. Who are those responsible for generating these digital certificates, these rowers? All those that have assigned IPv6 IPv4 or IPv6 resources. Whoever has an assigned IP resource has the responsibility of generating that rower. Semantically, a rower can be equivalent to what we saw in the IRR in the route and Route 6 objects, with an origin ASN associated to the information of the published segment of that ASN. An important thing that I would like to highlight is that previously, when we used to use IP resources, IPv4, IPv6 resources sub-assigned to us, for example, I'm a university, a final entity, and I use the addressing to publish my services assigned to me by the internet service provider. It's not addressing that I acquired from LACNIC, for example. So in the past, we depended on that service provider, the one that assigned me that segment would also create these digital certificates. But following a policy that was voted in 2023, the entities that have sub-assigned segments can now create rowers from the MILACNIC portal. So now it's not just that I acquired the resources directly from LACNIC, but if I received a sub-assignment provided to me by my ISP, I can visualize this in the MILACNIC portal, and I will be able to manage it and obtain that digital certificate. Compared to what we saw in the IRR model, in this case, the rower is done by the one who owns the IP segments. In the IRR, this used to be done by the ASN owner, if you recall. So this is also important to take into account. This here already mentioned, namely, what do we have to take into account? If we focus on this example of the network 203.0.112.0/22, we have to know whether the /22 is being published in a summarized way, the entire /22, or if we are breaking it down into blocks /23/24, and with what autonomous system these are being published. I'm always publishing that segment of the network, or if I also allow other ASNs to publish this. So having all this information, we have to be clear as to what is the policy in order not to invalidate our own publications. Remember that that is a policy that we have to follow, namely what is the autonomous system that originates my prefixes with what autonomous system am I announcing it, or if these are different autonomous systems, or if this is done broken down or summarized. If we respect that policy, we'll have our certificates properly created. They will appear as validated. If we were to validate it in a validating cache, these rowers will appear as validated, as well as the information of a router is a valid route. This you cannot see it very well, but this contains all the information. But the slides, the presentation will be available, showing you the step-by-step to generate the digital certificates in the MILACNIC portal. Remember, you have a username and a password at the MILACNIC portal to manage your resources. You access the portal. You have different users. You have technical level, administrative level. The idea is to enter with your technical username. You will see there on the left of the screen the RPKI service containing the information as to how to generate your row. You can generate multiple rowers, you can generate easy one by one, and all that information depends on how you are making your publications. When generating that ROA or when generating that certificate, this is a looking glass. This is RIPES. You will be able to visualize the status of all the prefixes for which we already created a certificate, if these are valid, if we have certain prefixes that are not valid, or if we have prefixes that are not found as a status. So these tools are then included in the presentation. And I don't know whether we have time for the demo, otherwise we can go over to the questions and we can have the demo after the break. So let us ask one question. Here we already did the recap. We see that there's a lot of information, theoretical information, and the demo of the IRR on the mechanisms we use for validation purposes, and the global validation structure that we have in Manner. So now we're going to ask a question to see who wins the first prize that we have for the tutorials. We have one for today. Sandra Reyes is a member of LACNIC staff and LACNIC campus, and she will be handing the first prize. So let us ask the first question. The person who has the answer, if you're in the room, not remote participants, because we cannot give you the prize, but you can go up to the microphone and give us your answer. The question before going to the break is the following. And we will have a second question after the break in order to give you another prize. So the question is, who creates the objects in an IRR and who creates the ROAs in the RPKI system? The ASN manager or the prefix manager? So go up to the microphone and say who creates the object in the IRR and who creates the ROA in the RPKI system. Please, let's see. Think well. I'm going to read the question again. Maybe we can put the question up on the screen.
Here, let me share the question for you to read it, think it over. We did that. We said that several times today, all along, and more specifically in this last half hour. There you are. Good afternoon. Good morning. The IP Resource Administrator. The IP Resource Administrator creates what? Well, they can create the object or the ROA, although I don't need to have an ASN. If I didn't have the ASN, I would give permits to the ASNs upstream. I'm Álvaro Sánchez from Costa Rica. Let's see if there's another. You are partly right with what you pointed out, but you think that because they have a resource, they are the owner of autonomous system. Not necessarily, and you say that the owner of the IP addressing can create both the object and the ROA. Yes, correct. Well, it's partially right. So let's see what the other colleague says, so we'll clarify it. Good morning. Well, the creator is the administrator of the ASN. The owner of the ASN creates the object in the RIR or the ROA in the system. In the RIR. Yes, it's also partially correct. Oh, we're using up all the prices that we have for the afternoon tutorial. Should I explain it now? Well, you have another one here. Please complete your response. We want it to be complete. You need to tell us who creates it in the RIR and who creates it in the RPKI system. The owner of the IP resource creates the ROA in LACNIC and how do you call it? And the other issue is created in the RIR. Right. That's the right answer. Yes, indeed. Remember, we told you that the difference, well, please. That's your name and what is Oscar Hernandez, Cable Color Honduras. Yeah, congratulations, Oscar. So now, let me give the floor to Sandra. Just to clarify, indeed, remember that in the RIR is the owner of the ASN that has the responsibility of creating the object. In the case of RPKI, if we don't have an autonomous system, but we have IP resources, we are responsible for generating the ROA. That is the IPv4, IPv6 resource, responsible for generating the ROA, but here to generate the object in the RIR, I won't be able to do it. Sandri? I don't want you to take any of your time. I'm Sandra Reyes. I'm part of the team. And now here we have some gifts because of a question. So I wanted to remind you that we have the Campus LACNIC. Specifically, I'm going to be at the booth very close to the trade show. So if you have any questions about the online courses that we provide, be there available for you just in case you have any questions. Thank you. Thank you, Sandra. Well, now let's go to the coffee break. And as we come back, we have another question. We have a 30-minute break. The coffee break is in the Jade room that is quite across the booths, and Jade is across the plenary. So we'll come back in half an hour to resume this tutorial.